Hello and welcome back to the December installment on the Energy and Sustainability channel. I'm Emma Brookes. I am the channel manager at DCD for the Energy and Sustainability, Construction and Investments and Markets channels, and I'm delighted to be introducing our next episode on APAC Data Centers, Smart Strategies for Scaling Sustainably. And thank you very much, of course, to CtrlS Data Centers for partnering with us on this episode. I'm delighted to introduce our four speakers for this session. So we have Dillip Guru, who is the Senior Vice President for ESG and Renewable Energy at CtrlS Data Centers. Karan Sinsinwar, who is the Technical Director for Sustainability at AECOM. Professor P.S. Lee, who is the Director and at the Centre for Energy Research and Technology at the National University of Singapore. And Darryll Howell, who is the Director for APAC at Red Engineering. So thank you very much to you all for joining me today. So to kick us off, I really want to cover the topic of scaling sustainably with green energy. As we know, when it comes to the scale of data center development that we're seeing, one of the biggest challenges is that availability of renewable power. So Dillip, if I could maybe go to you first. With India being such a rapidly growing market at the moment within Asia Pacific, what do you see as the potential of, for example, wind and solar in the region to support these workloads sustainably?
Thank you. Let's start to talk about India. In future years, India will add about 0.5 gigawatt of data center every year. And if we talk about renewable energy, India will add something like 30 to 40 gigawatt of renewable energy every year. That's almost 50 to 60 times of data center capacity. And when we speak about renewable energy, it includes wind, solar, hydro, which is a big component, and energy storage in different forms. Battery is popular today. Technology could change, but it's evolving. Talking about CtrlS, so far we have added about 65 megawatt renewable energy capacity feeding our Mumbai and Noida data center. And this was completed a few months back. By end of March 2025, we will double our renewable energy capacity. And we are further working to add all forms of renewable energy, that includes wind, solar, hydro, and energy storage, to deliver 100% renewable energy by 2030. Good thing is the prices of all different form of technology is coming down. And today, renewable energy can deliver 100% power to data center at a cost better than the grid price. And with keeping that in mind, we have a goal to be 100% renewable energy by 2030, where we will add about 2,000 megawatt of renewable energy across our operations. Most of them will come through self-built projects, and some of them through power purchase agreement. But to your question, yes, we see the advancement of renewable energy technologies as a great benefit to data center. And definitely this will help achieving 100% renewable energy in India and in other parts of APAC.
Fantastic, thank you. And P.S., if I could jump to you next. Dillip touched on some of the sources of renewable energy with his seeing, but when it comes to the APAC region more widely, whilst there is no silver bullet solution, which sources of energy do you think have potential to scale in the region in order to support these denser workloads that we're seeing? Do you think we'll see, for example, an expansion of alternative energies such as hydrogen and even on-site power generation?
Yeah, sure. I think as Dillip have shared, I think in the regions across APAC, I think certainly there's a very good potential for localized renewable energy solutions, particularly solar and wind, which will remain critical in regions like India, Australia, and parts of Southeast Asia. And increasingly, we are looking at the initiative like the solar wind hybrid systems, which are becoming viable solutions to manage the intermittency while ensuring stable power for high density workloads that we are seeing quite a bit. And as you pointed out, there's also a lot of interest in using hydrogen as a backup, in particular green hydrogen as a backup, and maybe even based load options. So while green hydrogen is still the scaling, it's actually gaining tractions for applications where energy security is crucial. And in particular, in space constrained locations like Singapore, right? So I think this is actually one of the options that we are actively evaluating. So it offers potential as a backup power source for data centers in region where grid stability is less reliable, and collaboration with hydrogen producers could pave the way for early adoption. And as another point that you mentioned, the on-site power generation with storage. So this is also playing a increasingly important role, especially with some of the grid infrastructure that actually requires quite a bit of capex to be expanded and upgraded. So in the interim, I think increasingly a lot of interest on-site power generation, right, and coupled with storage, for example, advanced battery storage systems. Such setup actually mitigates the grid dependency and provides operational flexibility, especially for remote or urban constrained sites. But I think there's also the scalability challenges, right? So for infrastructure like that pertaining to hydrogen, there's usually a high capital cost involved. And the need for technology to mature actually highlight the importance of near-term reliance on hybrid solution, combining renewables and battery storage. So I think it's like what you rightly point out, not a one-size-fits-all. It has to be solved as functions of the local conditions.
Yeah, absolutely. I think there'll be a combination of solutions for sure. No one size fits all. And as you said, some of the challenges with these sources, such as some of these power sources, such as hydrogen, is that scalability element. So it'll be interesting to see how that plays out. Karan, if I could jump to you next. I mean, what are you seeing from your side? So, for example, obviously there is quite a big variation in the availability of renewable energy on the grid in different parts of the region. So, how is the site selection process in Asia Pacific being impacted by climate resilience and risk exposure considerations?
It's a very good point, Emma. Being based out of Singapore, and we have the wider visibility of the entire APAC region, we are seeing that climate resilience and risk exposures are increasingly becoming integral to the site selection process, whereby we look at a couple of considerations. First is looking at different scenarios, the climate scenario analysis, whereby we look at projecting future climate conditions and what would be the impact on the potential sites, which includes evaluating risks from extreme weather events, sea level rise. Singapore would potentially be impacted by sea level rise and temperature fluctuations, which is quite critical for data center operation. Also looking into risk assessments, both physical risk, which is flooding, heat wave, transition risks, which is regulatory changes, market shifts. These are also assessed when we are looking into the site selection. These risks help in understanding the long-term viability and the compliance requirements for the site in APAC. And in the event we are looking at a brownfield site for data center, then what sort of resilience that infrastructure provides in terms of the building design, the structural stability, what sort of drainage systems they have, effectiveness of that, and the reliable consistent energy supply that can withstand the climate impact. So these are the key technical considerations that we look into when we start to talk about climate resilience and risk exposure considerations.
Brilliant, thank you. And last but certainly not least, Darryll, it'd be good to hear from you as well. I mean, we've already mentioned some I suppose the variations in the grid in the region and some of the climate risks that Karan sort of referred to. But given the intermittency of renewables in some regions, how do you see this sort of playing out in 2025?
Well, I think it will continue to grow because there's a demand and a need for it. It's backed by investment. Dillip's talked at length about India and the investment India is making on renewables. Other countries around the region, such as Japan, China, are investing heavily in renewables. The type of renewable that suits their environment. So Japan's more wind-based, maybe, whereas India's more solar-based at present times. You have the ASEAN networks, so the agreements being struck to capture solar energy in Laos or Cambodia, and with a cable send it down to places like Singapore. So that's definitely happening, and discussions of the same coming up from Australia. And then the government policies are sort of pushing industries, not just data centers, but heavy power users to adopt and pay for this sort of energy, whether it's via PPAs or direct feeds. And it depends which country you're in. Singapore, very hard to get a direct feed, limited land. But it's definitely a market that's going to grow. You're talking about battery energy storage, which is going to be key, for dealing with those peaks and troughs. You can store the energy when you're overproducing and discharge it when you're underproducing. And data centers can be a key part of that because of the need to have backup power on site, possibly in the form of batteries for your UPS. You can use them, you can monetize them potentially if you're a DC operator in certain countries, depending on the regulations that come in place. APAC's a little bit behind Europe in terms of facilitating that, but I think it's something that will happen because we're seeing the Energy Market Authority in Singapore at least starting to engage in demand response and what that means, and similar in Japan and Australia.
Thank you. I want to move us forward a little bit to talk around the sustainable design and construction. I mean, when we look at data centers, I suppose building in the sustainability comes right from the beginning of the process. So from PS, if I could maybe jump to you first. I mean, from your research, when it comes to, for example, the circularity of the data center, do you think we need to integrate that more closely into the design?
Yeah, I think certainly the circularity needs to be integrated to the design and even the operations of data centers. So maybe I'll share the number of ways that circularity can be actually embedded within the DC industry. So at first, we should be looking at circularity in material use, so adoptions of like modular construction practices or the use of recyclable materials are key. And I think there's also a lot of development in terms of prefabricated components, which can help streamline construction while facilitating reuse and recycling at the end of a data center's life cycle. And I think over the last the 1-2 years, we're also seeing a lot of interest in life cycle carbon assessment. So basically integrating the life cycle assessment tools during the design phase, which actually allows operators to minimize the embodied carbon by selecting sustainable materials like low carbon concrete and steel and energy efficient equipment. But I think we also can look at adaptability through modular design. And because modularity actually ensures that the data centers can scale with demand while they're maintaining the low environmental impact. So such design flexibility supports both immediate sustainability goals and long-term resource optimization. But last but not least, circularity, the framework, so we can be drawing from circular economy principles, design considerations, which actually helps emphasize the deconstruction and reuse by ensuring minimal material wastage during expansion or decommissioning. So I think certainly circularity increasingly needs to be part of the DNA when we talk about the design of the next generation data centers.
Yeah, absolutely. And as you said, we are starting to see so much more innovation with things like low carbon steel and low carbon concrete as well, which is great. Karan, if I could maybe jump to you next. PS has already touched on kind of the, I suppose, the sustainability and design principles, but obviously one of the challenges that operators have is, they have to adhere to obviously their tenants' requirements. So I guess how can data center designers, I suppose, adhere to those sort of sustainability principles and kind of, I suppose, find that balance in the middle?
Sure. It's not just the data center, but in general, the overall design of the project, which is quite related to having an early stakeholder engagement, engaging with the tenants to understand what are the sustainability goals that they have. Or the big data center providers, they have their in-house sustainability goals. So that could help to shape the operational needs while we are designing the data center, which meets both the environmental objectives and the business objectives. And quite often, these sort of collaborations can lead to innovative solutions that benefit all the parties. And what we have experienced is, if we were to look into sustainable operations of our data centers, like optimizing energy and water usage or regular monitoring and managing of the environmental impact, it is very, very important to engage the facility management team early in the design, so that we can get their feedback and include that into the overall project design. Prof. Lee has very rightly pointed out the two key things on modularity and adaptive infrastructure. So that modularity can also help to scale the data center operation efficiently based on the tenant's requirement, and without over providing the resources. We are looking into some of the data centers which can have provisions for district cooling systems or alternative cooling technologies. That is only possible if we know what is the sustainability objective of the tenant and how can we as a design team help to achieve it. And lastly, looking into sort of adaptive infrastructure that can also lead to a proper decommissioning, and designing infrastructure that can adapt to new technologies and changing tenants' needs. Because right now, there are a lot of advancements in the data center cooling technology, so our buildings should be able to cater to the changing tenant needs, which includes flexible power, different type of cooling systems, district cooling system provisions.
Yeah, that makes a lot of sense, and yeah, it's interesting, kind of what you mentioned that about that ability to be able to, I guess, adapt the building to higher power requirements if needed in the future. We're talking on the construction channel, we hear a lot about the sort of flexibility in design principles. So no, that's interesting to hear. Darryll, if I can, maybe jump to you next. When it comes to that circularity element, are we seeing much in the region at the moment in terms of things like waste heat reuse, demand response being built into design principles where possible in the region? Is this something that you see potentially scaling in the future?
Clients are starting to take an interest and look at this in the region. Some of that's driven by sustainable regulations and guidelines such as Singapore's Green DC Roadmap, and competitions like the CFA to earn the right to build your data center in Singapore. You need a demand, so you need a usage. So in cold climates, it's a bit easier. In Japan, you've got a potential usage for half the year of heating buildings. We've definitely seen it in Europe, where it's been practiced and exporting into heat networks in local towns. But you also need to be close to the point of use to make it economically viable. So again, we've done studies previously where it's just cost too much. Everything's too far away from where the data centers been put by the planners. Which comes to another bit. People need to start thinking of the data center as part of an ecosystem, and how to integrate it better into the urban planning where it can be of use. They're seen as dirty buildings, and they don't have to be. So you need to be able to position with co-adjacencies, maybe with industries that need the heat, and that's definitely stuff we're looking at in Singapore. A big change has been the adoption of liquid cooling, because now it's easier to capture waste heat and at a slightly higher temperature, which is more usable. So that's definitely, I think, we'll see more of over the next few years, and we are looking at it with clients in our master planning and designs now. Demand response, very big in Europe. say, very clear guidance and regulations that make it a real incentive. In Asia, catching up. So again, it's not really that prevalent in terms of being able to feed back to the grid. And in fact, at the moment, the regulations say for Singapore is that you can get paid for turning off your demand, but not for over providing. So you can do stuff where you can generate or have batteries on site. You stop taking for the grid, and for a certain amount of time, you could power your data center and get paid for not asking for stuff from the grid. It's not there yet where you're being paid for over providing and topping up the grid in those times of need. But again, that will change. Different countries will have different policies, and we'll just have to be nimble and agile with the business models that are moved forward.
Yeah, definitely. Well said. Yeah, Dillip, it'd be really interesting to hear your take on all of this as well. We've talked around sort of, I suppose, sustainability throughout the whole life cycle of the data center, construction, design, operations, even decommissioning. I suppose, how can sustainability, as an operator, how can sustainability be integrated into sort of all these different levels and processes?
Probably there are three aspects that needs to be considered, and we consider while designing a data center for the data center to be sustainable. The architecture, choice of technology and equipment, and choice of material. The last one is the easiest one. So steel and cement are the biggest thing that's used in construction of data centers. So using low carbon steel is an example that helps in having data center with lower level of carbon. When it comes to designing the data center with high efficiency, like variable speed drives, right? It is very common in other industries. Right sizing the equipment when you are doing your data center design. When it comes to architecture, design your airflow path effectively so that your cooling is efficient. So it's a combination of architecture, selecting the right equipment, and then choosing the right material while building data centers. These days, there are many suppliers who supply reused material that can be used for data center, and we also explore them as part of sustainable material in data center construction. So these are some of the choices that we use, and that's the way industry is moving in terms of sustainable data center design and construction.
Fantastic, thank you. Moving us forward to from the construction to discuss the sustainable operations. Karan, if I could come to you first for this one. Obviously, one of the challenges with high density workloads is, of course, the increased amount of power that is required. So, as well as looking at, for example, things like renewable power and battery energy storage systems, what are the steps that data centers can take, I suppose, to optimize their operations for better efficiency?
So, for any data center, the biggest energy guzzler is the hardware that they are using. So it's the lowest hanging fruit to look at low power servers and storage devices. But having said that, and my earlier point of stakeholder engagement, I think it should also be including the different hardware suppliers and providers, because it has been long believed that IT equipments, they need to run at a very low temperature, ranging between 15 degrees Celsius to 21 degrees Celsius. But there are studies done by ASHRAE, which recommends that the cold idle temperature, it can go up to 27 degrees C, which will not have a major detrimental impact on the equipment. And when we start to engage the hardware suppliers, the IT equipment manufacturers from the beginning, then we can also efficiently analyze what sort of specifications that they are putting for their machines. Can they run at 32 degrees C or 30 degrees C. And there are a couple of suppliers in the market that can do that sort of operation. So just increasing the coal line temperature from 21 degrees C to, let's say, 25 to 27 can help to reduce the energy consumption. And what we are also observing nowadays in the data center, the crack units, they are set to dehumidify the air down to a relative humidity of, say, 40%. And sometimes to reheat the air if the return air is too cold. And if we are able to tweak the operative temperature, that reheating requirement will also be taken out. So that's a bit on the operative set points in the data center itself. But we also look at some immediate steps as soon as we get hold of the design is to run computational fluid dynamics, which is looking at the airflow of the data center hall to determine the hotspot. So say, for example, if a certain UPS system area has higher operative temperature from our CFD analysis, then working with the mechanical engineer, we would be looking at optimizing the airflow and to serve the hotspot better so that there is an even cooling, which is maintaining the operation requirement of the DC plant. And lastly is also start to look at the data center infrastructure management, DCIM systems, which can help to monitor, manage, and optimize the data center resources and energy use. And those tools, there are a lot of them in the market. They provide great insights into what are the trends of the power usage, what sort of cooling efficiency, PUEs that the data center is getting.
Yeah, absolutely. P.S. I'll jump to you if that's okay, because I saw you nodding, nodding along to some of Karan's comments. So, yeah, it'd be good to hear your thoughts too. And what are the most significant advancements that you've seen from your side in terms of sustainable operations this year?
Yeah, I think certainly we're seeing a lot of advances in cooling systems. So specifically the shift to direct liquid cooling has actually brought measurable improvements in energy and water efficiency, particularly for high performance computing workloads. So this system can handle higher power the servers, and it's also able to use less water than the conventional chiller-based system, which typically comes with a conventional wet cooling tower. We're also seeing quite a bit of interest in terms of using or leveraging on AI to drive operational efficiency. So increasing AI machine learnings are transforming how data centers manage power and cooling loads. So AI and machine learning can be used for predictive analytics, which enable dynamic adjustment to PUE or even WUE, leading to operational efficiency without compromising reliability. And certainly, there's also a lot of development in terms of integration of renewable energy. Many operators now actually incorporate energy storage systems to better utilize the intermittent renewable power, reducing the reliance on fossil fuel-based backup system. There's also the development in terms of energy efficiency measures, right? Like the use of advanced power management technologies such as intelligent power distribution units and voltage optimization system to ensure that the energy is utilized efficiently across all operation loads. And I think all these measures are actually important, especially when we talk about, for example, the pre-training of AI models, right? And we expect a big fluctuation in terms of workload. So the challenge then is actually how do we actually ensure optimal operational efficiency, right? Even when the workloads is actually going through significant fluctuation.
Yeah, absolutely. That's a really good point regarding the fluctuations there. I mean, Dillip, if I could maybe come to you next. I mean, what are the energy efficiency principles that you've implemented at CtrlS in order to optimize your operations?
Sure. We have, the first thing we do is we do energy audit of all our data center every year. And This is the most fundamental way to improve efficiency in any data center. You do audit, you find equipment that are outdated, the cooling system is not efficient, sometimes you have to change a chiller or something like that, and they have significant impact on the performance and efficiency of the data center. The second thing is what Prof. Lee mentioned now. With use of AI and measuring probes, data center can operate at a much better efficiency level, utilizing less power and less water to serve the same data center. So we have started implementing AI techniques uh, to find operational inefficient points that are not efficient, or dynamically points that create issues, fix them either predictively or on spot uh, to improve our overall performance, both on water as well as energy. So, and in addition to that, we believe in utilizing most maximum renewable energy for our data center. So, energy storage is one form, completely agree, but we also try to put uh, mm, wraps or facades around data center so that we are able to extract any amount of renewable power we can get from within a data center, in addition to getting it from outside, so that our renewable energy usage inside data center increases. So these are the three steps we take: energy audit, use of AI to improve data center performance, both energy and water-wise, and third, using renewable energy within the data center to reduce the overall energy, energy usage.
Great, thank you. And Darryll, obviously we've touched a lot around the I suppose moves to liquid cooling. I suppose from your side, how do you see this? How do you see this playing out? And indeed, of course, one of the I suppose both challenge and opportunity with liquid cooling is that you do need these sort of skilled operatives with it to maintain the sustainability of the facility. So yeah, how do you see that playing out?
Yeah, it's interesting, isn't it? I think we've talked a lot about, you said, liquid cooling and the efficiency it drives. But yes, it's new systems. It's new systems within data centers. People are used to managing and looking after air systems, maybe some um, chilled water loops and cooling towers. And with the integration of renewable technologies as well, there's going to be new items of plant and distribution systems in the data centers. They aren't necessarily outlandish technologies. There are other industries that have used this sort of technology previously, but it's going to be very important to upskill the workforce um, to look after these systems effectively. It's no good designing a data center and building it, even and commissioning it perfectly, if you don't look after it. It is surprising that the number of times we go to audit a facility and you can see where things haven't been maintained because either the skills aren't there, so people don't know how to maintain something, so they sort of ignore it or turn it off, which is worse, or where maybe the investment just hasn't been made in preventative maintenance, and people wait for something to go wrong before they try and fix it, and then you see chilled water loops that are full of sludge, which means the pump's working harder. Don't have the same heat and carrying capacity. It just affects the efficiency and operation of the data center. There are opportunities. In the region as we move to renewables, you will see probably people in the petrochemical industry looking for new work. They would have transferable skills. So with potentially a minimal amount of retraining, you might find there's a pool of skilled maintenance operatives available there. That may be something that Singapore looks to with the repositioning of somewhere like Jurong Island in the future, but we'll have to wait and see what happens. So yes, you can do all you want in the world, design-wise and construction-wise, but you need to look after it, and it spends 20 years being operated. Uh, that's where all the carbon is, and the money is in the operational period.
Yeah, absolutely. That is very true. You mentioned there that a lot of the carbon emissions are in the operational period, but when we, I suppose, again look at sort of the LCA cycle analysis of the data center, we are, companies are of course increasingly conscious of accurately tracking, their carbon footprint, etc. And that can be from, as you mentioned, the operations and of course, indeed the supply chain as well. So yeah, Darryll, if I can come back to you again for this one. Of course, we are starting to see more progress in terms of things like environmental, product declarations. I mean, what have you seen in terms of EPDs in the APAC region, and is there anything in particular that kind of Red Engineering is doing in this space?
So at Red, we developed our own internal carbon embodied carbon calculation for the MEP systems we design in data centers. It is much more advanced in Europe because there is more information available. The manufacturers are quite organised and have a lot of the details and information that you need and look after, down to the carbon involved in the transportation from the factory to the site. APAC is a little bit behind. The information isn't as available across the board. The one interesting thing where we've done the study on some data centers to try it out, still the embodied carbon in the materials is really quite insignificant compared to the carbon in use if you are not using a renewable energy source. So it dwarfs it, to be quite frank. So the key thing still is to get renewable energy at the moment if you want to reduce your carbons. But we're now in a position where we can track it, and as people start to need to report their scope 1, 2, and even, well, maybe not 3 potentially emissions going forward for financial investment parties, then we're starting to get a position where that is possible. But it's there's still some holes, but it's getting better.
Yeah, absolutely. I saw a couple of nods there in your comments about renewable energy as well. Of course, that is the number one factor that has the biggest impact on the sustainability of the data center. But when we look at it as a whole, obviously there are things, for example, e-waste management, servers being replaced. And as a sector, do you think we need to kind of get better on e-waste management? Dillip, if I could come to you for that question. I mean, what are there any sort of initiatives that CtrlS has implemented in this space?
Sure. So when it comes to EUS, there are again 3 basic principles, right? Extend the life of the product, reuse if you can, or recycle. So and if we talk about component, it's battery, monitors, computers, most of these things. Good thing is the new age equipment are coming with longer life cycle, and with a little bit of test evaluating them, their life can be elongated. And anything that we avoid or we are able to make the life slightly longer is a boon to the nature. And after the life expires, we try to work with vendor, or rather we work with vendors to see if they can be reused with certain modifications, etc. And we have been successful in that, to reuse material after refurbishing. And the last option that we take is recycle if it has reached end of its life. Obviously, there are data protection, destruction. There are other things that goes into that. Not this subject is not about that now. Taking care of them. How do we recycle those products? And we have tied up with vendors who recycle these products. As we speak, 100% of our e-waste is recycled every year, and we work on those 3 steps I mentioned. This has helped.
Yeah, absolutely. Great. That's great to hear. P.S. I'll come to you to circle back on something that Darryll said, which was on scope 1, 2, 3 emissions tracking. As an industry, we have seen these sorts of effort to move towards accurate, I suppose more so scope 1 and 2 tracking. What's your view on this? I mean, do you think with scope 3 emissions is the industry, I suppose, trying to run before it can walk?
I think certainly compared to the scope 1 and scope 3, there are actually challenges associated with scope 3, which actually covers like supply chain and upstream, downstream activities, which actually remains difficult to quantify. So standardized frameworks such as those proposed by Greenhouse Gas Protocol are still being implemented inconsistently. But I think that there are still things that we can do, right? Certainly, I think it needs to be highly collaborative. So collaboration with suppliers to share emission data and align sustainability targets slowly but gaining tractions. Additional life cycle tools that evaluate the environmental impact of equipment manufacturing, transportation, and disposal are evolving to aid in the scope 3, the transparency. So while progress is actually slow, but I think we are seeing more of these evidences. So the complexity of scope 3 tracking means that the industry must actually focus on harmonizing methodologies before scaling these efforts. So I think more work certainly needs to be done. And I think if we adopt a highly collaborative approach, I think more progress can be made.
Yeah, absolutely. And Karan, it would be great to hear your take on all of this as well, and how you're, I suppose, integrating design principles that will incorporate the whole life cycle of the data center.
Well, when we talk about the whole life cycle of data center from design to decommissioning, you're talking about multiple years, 20, 30 plus years. While those period of years help to give an opportunity to improve on energy efficiency year by year, but the materials which get constructed are in the building itself. They are part of the overall embodied carbon, kind of embedded embodied carbon. So it's quite important to look at embodied carbon, and especially in countries where the grid is decarbonizing quite quickly, with the overall net zero commitments that different countries have. So as the grid is keeping high pace in decarbonizing, it's important to look at the embodied carbon for structural part, concrete, steel, and as well as MEP part. And we use one-click LCA tool to carry that out. And again, when we are talking about the whole life cycle, it's not just the design. Quite often, construction phase is overlooked. There are certain companies in Singapore over here which are looking into quite high sustainable construction practices of minimizing the waste, material recycling, and reducing the emissions using biofuels for construction equipments. And a big chunk is the operational phase of the overall life cycle of the data center. As rightly mentioned by Properly earlier, use of AI will help to implement robust data center infrastructure management, which can help to monitor and optimize the energy use throughout the life cycle of the project.
Mm-hmm. Thank you. We've got about 10 minutes or so left, so I want to use this time just to briefly touch on something that was mentioned earlier, which is water management, and obviously the circularity element there. Obviously, we do see some regions in Asia Pacific where they are water strained. There isn't an abundance of water available. So, Dillip, if I could maybe come to you first for this one, what do you think is the potential for recycling and reusing water in data centers in the Asia Pacific region?
Going forward, the water will be a key issue in many countries. India is already seeing that. Many places where data centers in India are there are already water scarce. This could translate to many other countries. So, understanding the usage, recycling, reusing of water it's mandatory. Like, think of Singapore, they have this concept of new water, right? They completely recycle water to bring new water, and that is eventually going to be potable, but definitely for industrial use. What we are doing in CtrlS is whichever city or whichever town we operate, we work with the local municipal development corporation to provide us recycled water. We have successfully done that in Mumbai, Hyderabad, Bangalore, quite a number of cities where we get recycled water from the municipal for our data center usage. This helps in terms of straining the water resources. Obviously, recycling water is another great way of reducing the entire water usage. And we have a principle of zero discharge. So most of our data centers work on zero discharge principle today, and that's how data centers are designed. Importantly, whatever water we are still not able to offset and we are consuming, we are planning to build water reservoir in water scarce places, which can eventually offset additional water that we are consuming. Overall, we are planning to be net water positive by 2030 through combination of use of municipal water, recycling, and then offsetting it through creating water resources in places where uh, there is already water scarcity. So that's something we are doing in CtrlS.
Fantastic, thank you. And the PS, what's your view as well on sort of how, I suppose, better water circularity can be designed into the data center from the beginning?
I think as Dillip mentioned, I think one way certainly is actually wastewater reuse or recycled water, especially for water scarce regions, right? So adopting such innovative approaches can actually leads to the single freshwater savings. So it also promotes circularity by reducing the need for freshwater resources. The other will be actually the use of closed loop cooling systems. So this system can significantly reduce water consumption by recycling the same water within the cooling processes, and advances in filtration and treatment technology further enhance the efficiency of such closed loop system. But I also want to caution there can be trade-off between water and energy efficiency, right? So air-cooled solutions may reduce water usage, but often results in higher energy consumption. So data center operators must evaluate these trade-offs and actually tailor solutions to regional resource constraint and climate consideration. But I think there's also the more things that can be done if we adopt a collaborative water management, right? For example, the collaboration with municipalities or industry to share water resources, particularly for industrial and district cooling system, can actually amplify the impact of water saving initiatives.
Yeah, absolutely. And you mentioned there the potential trade-off in reducing water usage in data centers. Yeah, Darryll, I think that was something you mentioned previously as well. For example, air-cooled chillers can drive up energy consumption.
Yes, very much so. I mean, it's very simple to design a data center with WE, and that's to use air-cooled chillers, or dry air coolers now, potentially with the higher temperatures from AI chips. But it does depend on your chip manufacturer. Some chip manufacturers are asking for 35 water on, some are still asking for 26. So it does depend on the end user, the end customer, and what they're asking you to design for. There are some interesting things we're looking at. We've read in terms of taking waste heat from on-site power generation to drive desalination. So you can, if you're near the coast, you can generate water, more than enough water that you need for your data center, and provide some for other usages such as potable water supplies or industrial water supplies. The drawback is land. You need quite a bit of land for that sort of system. But there are things that can be done to make you water positive on a site basis if you're in the right location. Again, with design of data centers, heat rejection is going up. Cooling towers are still the most high capacity way of rejecting heat. Where you're building 1 or 2 story data centers over a large floor area, it's quite easy to go to an air-cooled chiller or dry coolers that take a bit more space. Where you're building 5, 6, 7 story data centers in somewhere like Singapore or Hong Kong or Japan, not so easy. You might not get the heat rejection you need unless you're using cooling towers. So again, you have to, as PS Lee says, you have to take in consideration the constraints of the site you're on and the locality you're on and the weather conditions. Again, somewhere like Japan, Korea, you get a very cold season, so you can get quite a lot of free cooling out of an air cooled chiller for a lot of the year. So the trade-off isn't so bad up there.
Yeah, makes sense. And Karan, it'd be great to hear your thoughts on this as well from a design perspective.
Yeah, I think PS, Darryll, and Dillip, they've covered all the points. But what we at AECOM are looking at in a couple of our data centers, which are in design phase, or as well as when we are looking into the operational phase, is quite often the monitoring trends that the data centers are tracking. They're able to tell us what sort of water consumption, peak and troughs we are able to achieve. So that is, water metering and monitoring is quite helpful for water management and identifying the areas of improvement. And one last thing that I would also want to say is, while we can look at a lot of alternative water usage, in Singapore we've got the liberty of new water use for data center operations, but it's also important to, in the design, to look into implementing leak detection systems, because if we install advanced leak detection systems and we track it against what sort of trend of water usage there is in the building life cycle, then the leak detection system can help to identify the areas and address the leaks promptly, which will help to reduce the water wastage during the operation stage.
Yeah, absolutely. Really good point. Dillip, PS, Darryll, Karan, unfortunately, I'm going to have to wrap it up there because we are out of time. But thank you so much for joining me to discuss APAC data centers and smart strategies for scaling sustainably. Yeah, I've really enjoyed our conversation and hope that you have as well. Thank you very
much.
Thank you.
Thank you very much. Please do reach out to the speakers and send in any questions if you have any. They will be forwarded on. And of course, thank you very much again to CtrlS Datacenters for partnering with us on this episode. Do check out the resources for some further information, and don't forget this episode will be available on demand. We'll be back on the Energy and Sustainability channel for more content next month. But until then, Dillip, PS, Darryll, Karan, thank you very much for joining me.